Hello gladiators. Here is the key for our test review. It will include the answers and the explanations on how to get to those answers. So we're going to get started. Make sure that you check that your answers are correct. Also, if you do not understand a problem, make sure that you make note of that problem so you can ask a teacher tomorrow in class. All right, let's get started. For numbers 1, 2, and 3, we are going to convert the given number into the other two forms of the same number. So we're going to come up with equivalent forms given one of the types of numbers. So in number 1, we're given 3/4 as our number. So what we're going to do is I'm going to use equivalent fractions really quickly and multiply the numerator and the denominator by 25. I've done this because I want to make the denominator a place value, and I've picked 100. 25 times 3 is 75. So now I've got 75 hundredths. Well, 75 hundredths, written as a decimal, of course, is 75 hundredths. And then once I have the decimal form, I can multiply by 100. And since I've got 2 decimal places here, I have to have 2 decimal places here. And that gives me my percentage. Originally I had 75 hundredths. Multiplying by 100 virtually moves the decimal 2 places to the right. So instead of having 75 hundredths, it becomes 75, which is my percentage, and that goes here. Number 2 gives us a decimal. So again, if I multiply by 100, it moves the decimal 2 places to the right. That gives me 95% as my percent. Now, to get my fraction form, I take the place value of my decimal. My original decimal was 95 hundredths, and I'm gonna say it. So 95 hundredths. I'm gonna write it 95 hundredths. And then I'm going to simplify if necessary. So I'm going to divide by 5. When I divide by 5, I get 19 as my numerator and 20 as my denominator. That does not simplify any further. So I've got my answers. Number 3, we have a percent. All right, so to get from a decimal to a percent, like we did here, we multiplied by 100, which moved the decimal place 2 places to the right. To get from a percent to a decimal, remember the decimal is next to the percent sign, between the percent and the last digit. So we're going to divide by 100, which virtually moves the decimal to the left 2 spaces, which gives me 65 hundredths as my decimal form. Now, if I want to change a decimal to a fraction, again, I've already said it, 65 hundredths. Now I'm going to write it, 65 hundredths. And once again, I'm going to divide by 5 to get my simplified fraction. 65 divided by 5 is 13. 100 divided by 5 is 20. And that is my simplified fraction. That is how you complete one of these tables for conversion from fractions, decimals, and percents. For number 4, Fez is a repairman for an appliance company. On Monday, he drove 82 1/10 miles for his repair jobs. On Tuesday, he drove 82 1/3 miles. On Wednesday, he drove 82 and 3/10 miles, and on Thursday he drove 82.45 or 82 and 45 hundredths miles. It wants us to put the miles in order from least to greatest, and I'm going to circle that or box it so I know I need to start with my lowest number value and go to my highest number value. So I'm just going to start with 1. Let's say I've got 82.1. Then I need to move on to my next number. On Tuesday he drove 82 and 1/3. Well, 82 and 1/3. 1/3 I know is 3 repeating, so that's going to be my decimal form of 82 and 1/3. On Wednesday he drove 82 and 3/10. 82 and 3/10. That is 82 and 3/10. We don't have to do any conversions there. It's a straight place value because tenths is a place value. And then on Thursday he drove 82 and 45 hundredths miles. And I have put them in order because the place value is in numerical order. I've got 10 hundredths, 30 hundredths, 33 hundredths, and that repeats, and 45 hundredths. This is in order from least to greatest. So on this type of a problem, you want to convert all of the numbers either into decimal form or into fraction form. So we want to make them all the same. And then we want to make the decimal form, if we convert them to decimals, easy to compare. So I just put them all in hundredths. And that's how you do that problem. For number 5, it wants us to explain the difference between -7 and the absolute value of -7. Well, -7 means the opposite of 7. It's a place on the number line. It's an integer. Okay? And then we've got the absolute value of -7. Well, the absolute value of -7 means how far is -7 from 0? And the answer to that is it's 7 spaces away from 0, or 7 units from 0. So you can see that the number -7 does not mean the same thing as the absolute value of -7, and that's the difference. We're talking about the number that is 7 units away from 0 here, but on the negative side, and over here we're trying to figure out how far is -7 from 0. It's a very, very touchy little idiosyncrasy, but that is basically the difference between those two numbers. We're not trying to calculate a difference. I want to know what is the difference between the two numbers. How do they differ from one another? Okay? Number 6. Excuse me. Number 6, the question asks, what is the difference between the absolute value of point W and the absolute value of point Y? So we have to look at the number line that we're given. We're looking for the absolute value of point W. So we're taking the absolute value. Point W is at -8, so we're going to take that absolute value, and we're going to subtract it from the absolute value of point Y. Point Y is -2. So, since the operation is outside of the absolute value signs, we need to calculate the absolute value first. The absolute value of -8 just asks how far is -8 from 0. It's 8 units. How far is -2 from 0? It is 2 units. So once we have calculated the absolute values, we can do our subtraction to find the difference. And that is 6. The difference in the absolute value is 6 units. All right, for number 7, the problem asks you to explain the two ways to convert 8/20th to a decimal. Okay, it's not asking you to do it, it's just asking you to explain how to do it. Now, well, now to explain it, we kind of have to do it, so we're going to look at the two different ways. The first way is to find an equivalent fraction and the second way is to use long division or to divide the fraction out. So if I've got 8 over 20, to calculate the equivalent fraction, I need to convert the denominator to a place value. Sorry, my hands aren't working right. A place value. That place value is, we're trying to make this equal a number 10, a number 100, or a number 1,000. Well, I can divide by 2 to get to tenths, but I have to do it to the both. So then we're going to divide by 2, and I get 4/10. So now I've converted it to a decimal because I can make that 4/10. So step 1, multiply or divide to get a place value. I could have gone up to 100, and let me show how that would have looked. 8 times 20, 8 over 20, I could have multiplied by 5, and I would have gotten 40 over 100. Well, 40 over 100 simplifies to 4/10, and then I can make it a decimal, and 4/10 was my answer over here. Long division is just like it sounds. First, we're going to divide the numerator, which is 8, by the denominator, which is 20. We need to place a decimal and some zeros so we can divide it out. 20 goes into 80 4 times. And I have a remainder of 0, so I can stop. So my answer is 0.4 or 4/10. And you can see here that I've gotten the same answer in both places. So we're done. So the explanation on long division is just divide the numerator by the denominator. We need to add some decimals and then divide it out. And that ends section 1 of the review. So I'm going to move on to section 2 now. We're going to classify real numbers. So now we're talking about sets of real numbers. And I'm starting off with number 1 here, -5. So I'm going to place a check mark in each box the number can be classified. So we're going to check off every single category that it fits under, every one of the sets. So for number 1, it's -5. -5, I have to ask myself, is it a natural number? And it is not a natural number because natural numbers are counting numbers. -5 is not a counting number, so it's not a natural number. Is it a whole number? No, the only difference between whole numbers and natural numbers is 0. So the natural numbers and the whole numbers are the same with the exception of adding a 0 in. So if it's not here under natural, it's also not here under whole because it's got a negative. There are no negatives in either of these sets. That moves us to integers. So we have to look, is this the opposite of a whole number? Because the definition of integers are the set of whole numbers plus their opposites. Since this is the opposite of a whole number, we know it's an integer. Okay, and then to find out if it's rational, well, we just need to be able to write it as a fraction. And I can write -5 as a fraction by just putting it over 1. So it has to be rational as well. For the second one, 1/3, is it a natural number? Natural numbers are counting numbers, so we can't count 1/3 of anything. I need to be able to count it. Is it a whole number? No, it is not, because of the fact that it's a fraction, and we cannot put 1/3 into the whole numbers because it's the same. This set is the same as the naturals with the exception of adding 0. So it's not a whole number. Is it an integer? Well, it doesn't fit into the integers either because it's not an opposite of a whole number. So the only situation it fits into is rational, because if I divide it out, I get a terminating decimal, which is I get a repeating decimal. I apologize. It is going to repeat 0.33 or 33 hundredths. The 3 is going to repeat forever. It is rational. For number 3, I've got 10 over 2. Well, if I simplify this, I get 5. 5 is a counting number. I can count 5 items. So if it's a counting number fits into the whole because they are the same with the exception of adding 0 into my set. The integers include the whole numbers, so I need to include it in the integers. And the rationals are as well because I can make a fraction out of 5 and it perfectly fits well into the rational numbers. For negative absolute value of 7, I've got to calculate the absolute value of 7, which is 7. It's 7 units away from 0. But it stays a negative because I've got this negative imaginary 1 out here, my negative 1, that I have to multiply the answer by. Negative 7 is my answer. Is it a natural number? No, it's not a counting number, so we've got to skip that. Is it a whole number? No, so we've got to skip that. Is it an integer? It is the opposite of a whole number, so we have to count it in the integers. And I can make a fraction out of it by placing it over a 1, so it's a rational number. So that is what your table should look like for 1, 2, 3, and 4 in section 2. All right, number 4 shows another table, and it gives the heights of 4 students, and you can see the heights are given 49 over 5, 36 over 8, 144 over 12, and 75 over 12. So we need to divide these out, or we need to evaluate them to see what we get, and we're looking for the height that's a whole number. All right, so we got 49 divided by 5. I know 49 goes into 50 10 times, so this can't go into that. So we're going to multiply by 9. 9 times 5 is 45 with the remainder of 4. Now we don't use remainders in middle school, and eventually you'll see this. This remainder becomes our numerator, and our divisor is our denominator. So our answer is 9 4/5. If you divided this out to get a decimal, you're going to get 0.8. So 9 8/10. For rows, we've got 36 divided by 8. 8 goes into 36 4 times with the remainder of 4. 4 is my numerator, 8 is my denominator, so that becomes 4/8, which is equal to 4.5, or 4 5/10. Okay. 144 divided by 12. Well, I know that 12 times 12 is 144, so I don't need to do the long division. And I know, since I don't have a remainder, that this is a whole number. So the answer for this one, I don't even have to go on to Sam, but the answer for this one is Mark's height is a whole number. For number 5, we're going to place the numbers in the correct location on the Venn diagram. So let's look at the numbers. We have 5 2/10, negative 8, 7, and 3 over 2. So 5 over 2, we're going to go right down the list. We're going to start with rational, and we're going to work our way inside and see which one it falls under. 5 2/10, is it a rational number? 5 2/10 is a rational number. We can write that as a fraction. 5 2/10. 5 2/10. which becomes 5 1/5. So it can be a rational number. The question is it an integer? I need to know the definition of integer, which is the set of whole numbers and their opposites. This is not a whole number or its opposite, so we cannot come any further to the inside. We have to leave it as a rational number. -8, we don't have to evaluate -8 at all. We're just looking at it here. Is -8 a rational number? Well, it is, because I can write it as a decimal. I'm sorry, I can write it as a fraction or a decimal, because I can make it 8 0/10 as a decimal. Now, is it an integer? So we have to ask ourselves, is it a whole number or its opposite? Well, this is the opposite of a whole number, so it is an integer. Okay, and then we have to ask for the next section, whole, is -8 a whole number? No, -8 does not fall within the whole numbers, so we have to classify it as an integer. 7 is a rational number because I can put it over 1 to make it a fraction. It is an integer because it is a whole number. Remember, integers are the whole numbers and their opposites. And the next question is it a whole number? And the answer is yes, it's a whole number. So since I don't have a square in here for the natural numbers, then we're going to omit natural numbers. We're not going to worry about that for this particular problem. And the best situation that it fits into for this drawing is whole number 7. Okay, if I had a natural number category here or a box, I would place it in the naturals, but since I don't, we're going to leave it at whole. 3/2 is a fraction, so that's a rational number. Is it an integer? Is it a whole number or its opposite? No. So 3/2 has to stay a rational number. For number 6, the question says, name a number that would not be classified as a whole number and recorded in the grid. So we're looking for it not to be a whole number, not to be a member of the set W. So what are we left with? If it's natural, it's going to be inside the whole, so it is going to be a whole number. But we're looking for it to be an integer or a rational number. So I'm just going to go all the way to the outside, and I'm going to say 5 1/2, 5 5/10 is a number that cannot be classified as a whole number and record it. So we're going to record it on the grid here. 5.5, 5 5/10. Color in our gridable. Now you could have given a lot of different numbers. You could have given me any decimal, any fraction, but we don't have a way to write fraction on here, so we would have to convert it to a decimal. 1/2 is 5/10. Okay. Technically, you could have given me a negative number. -5 is not a whole number. So you could have put a negative out here off to the side. That would also work. Number 7, circle the true or false. If true, explain your answer. If false, provide a counterexample. Some rational numbers are a whole number. Some rational numbers are a whole number. So do I have rational numbers that fit within the whole number? Yeah, that works. Let's say 6. 6, I can make a fraction, so it is a rational number because it's a fraction that terminates. So the answer in this case is true, and that's the explanation. 6 can be written as a terminating fraction. Can be expressed as a terminating fraction. And that's the last question in section 3. I apologize. That's the last question in section 2. We will be beginning section 3 right now. So for section 3, coordinate graphing, the problem number 1 says 4 points are graphed on the coordinate grid. So we've got 4 points here. Is the ordered pair 5/2, 3, one of the points. So we're looking for the ordered pair 5 over 2, 3. Notice this is a positive number, this is a positive number, so I know that it has to be in quadrant 1 because this is the positive side of my coordinate plane. So if I go to 5 over 2, well, that's not really easy to see what it is. So let's divide 5 by 2. 2 goes into 5 2 times. And here's my remainder, which becomes my numerator over here. So I've got 2.5. So if I go across to 2.5, and then I go up to 3, that point would be right in here somewhere. And none of these points fall on that. So the question, is it one of the points? Your answer is no. For number 2, Kyle was at the library. He walked 1 block west and 2 blocks south. If each unit represents a block, to which house did Kyle walk? So he started off at the library. So he's right here. And it's not, notice your axes are labeled north, south, east, and west. So we're at the library and we walk 1 block west, so that's in this direction, so we got to go 1 block here, and then we've got to go 2 blocks south. South is in this direction right here, 1, 2. So if you walked with the directions given, you had to wind up at Grace's house, and that's your answer. He walked to Grace's house. For number 3, we're given a fancy word here, vertices. Right? A vertices, as far as shapes or geometry go, a vertex or vertices, the plural, is the corner. So if you have a shape, your vertices are where the edges come together. So we've got 4 vertices here given by these ordered pairs. The first one is at -2, 5. So we're going to go -2, 2, 3, 4, 5. Up there, that's a W. X is at -2, 3. 1, 2, 1, 2, 3. That's X. Y is at 4, 3. 1, 2, 3, 4. 1, 2, 3. And Z is at 4, 5. So we've got 1, 2, 3, 4. 1, 2, 3, 4, 5. So now I've got a rectangle, and I'm going to connect them just so that you see it a little bit better. So now I've created a rectangle with those points as vertices. The question is asking, determine the perimeter of the rectangle. So the perimeter, okay, is the distance around the edge of a shape. So I know we haven't taught that this year, but you have learned perimeter before. So all you need to do is start off at one of the vertices. We're going to start off at W because that's where we started drawing it. And you're going to count the distance as if you were walking all the way around the perimeter. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units all the way around. The perimeter is 16 units. Now, you could have just counted one of the sides here, which is 8. It is 1, 2, 3, 4, 5. It is 6. And then you double it, because we've got 2 of those sides, so 6 plus 6 is 12. And then we've got 1, 2 here, and we double it because we've got 2 of those, so that's 4. 12 and 4 is 16, and you get the same answer doing it that way as well. All right, number 4 has a big paragraph, and it really doesn't give you a whole lot of information. We're only given a few things, but it just takes a lot of words to read this one off. So let's look at it. Sam plots the point S on the grid as shown in the graph here to represent the stadium. He plots another point that is the same distance from the y-axis as point S, but on the opposite side. So the distance from the S, the stadium, to the y-axis here is 4 spaces. 1, 2, 3, 4. If he drew another point the same distance away from the y-axis, he's got to go 1, 2, 3, 4. So it is right here. Those are the same distance from the y-axis. He labels the point L to represent the library. Write the ordered pair at which L is located. So we need to write the ordered pair. So we're going to need to go in the x direction. 1, 2, 3, 4. So my x in my ordered pair is going to be 4. And my y direction is up. 1, 2, 3 is 3. So my ordered pair is 4, 3. Then it asks, what is the distance between the library and the stadium if each unit on the grid represents 5 miles? So we can do this one of two ways. I can count by 5s because each one of these distances is 5 miles. So we got 5, 10, 15, 20, 25, 30, 35, 40. Or I can count the units, 1, 2, 3, 4, 5, 6, 7, 8. And I know that each unit is 5 miles, so that also gives me 40 miles. And those are your answers. Last question. Write the ordered pair that represents the following points. So we're given a table here with 4 points on it, E, F, G, and I. So we're looking at E. Let's find E. E's right here. So E's ordered pair is 1, 2, 3, 4 to the right, and 1, 2, 3 down. 3 down, remember down is negative, so my y coordinate has to be negative. So E is at 4, negative 3. F, the next one, is here, so we're going to go 1, 2, 3, 4, 5 to the left, which is a negative 5. Remember, the left is negative on our coordinate plane, and then we're going to go 1, 2, 3, 4 down. Again, down is negative, so we have F at 5, 4. G is here, so we've got 1, 2, 3, 4 to the left. That's negative 4. And we move up 1. So up is positive, so we move up 1. And then the last point is I. So we move 1, 2, 3, 4 to the right. And we move 1, 2 up. 4, 2. So the ordered pairs that represent those points are given here, and those are your answers. Okay, that was the last question for section 3. So you should be able to come into class tomorrow with any questions or any situations, any problems, and make sure you ask those either on Friday, which would be perfect, so we can go over them in class, or at the very latest Monday before the test is given. All right, thanks for listening, and remember, it's always a great day to be a gladiator.